This is section 8.4. This is the second part. We're going to identify the shape given the markings. So we're going to give the most specific name for the quadrilateral. This first shape that we see, I notice that we have opposite sides congruent. That's what the markings mean. That guarantees that the shape is a parallelogram. Now, it could be a rectangle, rhombus, or square if you knew more information, but we don't. That's why that's just going to be a parallelogram. Same thing with this guy. You have one pair of opposite sides congruent and parallel. That makes it a parallelogram. The next shape over here, opposite sides are congruent. That makes it a parallelogram. And notice how all four sides are the same. That makes it a rhombus. The next shape over sure does look like a parallelogram. Sure does look like it might be a rhombus. We're going to call it a quadrilateral. There's no markings on it that guarantee that it's anything other than just a four-sided shape. Same thing with this guy. Sure does look like a rectangle. You can't say it's a rectangle unless you have markings. Okay, markings on this next one show that your opposite angles are congruent. That's a parallelogram. Could it be a rhombus? Sure, but we don't know anything about the side lengths. Next one looks like a square, no markings, so it's just a quadrilateral. We're going to call this next one a quadrilateral as well. You have one pair of opposite sides parallel, one pair of opposite sides congruent. If that was the same pair of opposite sides parallel and congruent, then it would be a parallelogram. But that's not what's marked. Next guy down is a square. That's because it's a rectangle and a rhombus, given the markings. This guy's a parallelogram, given the markings, opposite sides parallel. That's a rectangle, four congruent right angles. And this guy's a parallelogram. The diagonals bisect each other. Let's learn a little bit more about each specific type of rectangle, rhombus, and square. Theorem 811, you can mark this off in your theorem packet. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So if you have a parallelogram with perpendicular diagonals, that has to be a rhombus. And vice versa, if you have a rhombus, those diagonals are going to be perpendicular. That means, guys, that you end up with four right triangles in a rhombus. Theorem 812 says that a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So notice the markings there. Theorem 813 is about a rectangle. A parallelogram is a rectangle if and only if its diagonals are congruent. Notice the markings on those pieces of the diagonal. Since it's a parallelogram, the diagonals bisect each other, but if they're congruent, then all four of those little pieces are going to have the same markings. So you end up with four isosceles triangles in a rectangle.